Good morning, ladies and gentlemen. I'd like to welcome you to this webinar. My name is Byron Novo, and I'll be your organizer for the session. And with me today is Steve Van Zyl. I have a short video I'd like to play before handing over to our presenter.
As a Happy New Year and welcome back gesture, Articulated offers a heat pump installation course with a whopping 10% discount. Consisting of 7 modules, this course provides knowledge about the types of heat pumps available, the economic benefits of heat pumps, and a basic overview of the SANS 1352 national standard. To expand your knowledge about heat pumps and for a chance to earn yourself 5 CPD points, register for this online course at www.iopsatraining.co.za today.
That's it from my side, and I'd like to hand over to our presenter.
Thank you, Byron, and good morning to our listeners. Thank you for joining us this morning. My name is Steve Van Zyl. I'm the National Technical Manager. Today's topic is really a very basic introduction to domestic air source water heating heat pumps. If at any stage in my presentation I mention heat pumps, or maybe it is written somewhere heat pumps, please note that I'm actually referring to the domestic air source water heating heat pumps. Heat pumps are definitely, I want to kick off by saying heat pumps are definitely an alternative source or solution to heating water, and it's normally at a fraction of the cost if you have to compare that to a standard electrical geyser, which only uses an element, and obviously that is expensive. As we know, electricity is expensive to heat water. So let's take a look at the next slide and discussion points which I wish to cover in today's session. Next slide, Byron. All right, we'll take a look at some basic components of a heat pump. I'll be talking you through some of the workings and process in a very simplified manner, which I hope is easy to be understandable. Why are heat pumps so popular? Which installation standard is used for the installation of these heat pumps? The confusion between a split and an integral heat pump, I hope to touch on that and explain to you the difference between a split and an integral heat pump. And then I'm going to try and close off really with some of those common questions that we do receive, and that we'll cover under the last section. With that being said, Byron, can you move to the next slide for us, please? So in this slide, what you should be seeing is some of those basic components found in a heat pump. So to the left, you'll see there's a fan, there's an evaporator. To the bottom right, there's a compressor, there's a heat exchanger. It's very similar to like a radiator looking thing on the right-hand side. And obviously we have an expansion valve. And then obviously I've made a little note there saying ambient air right next to the fan on the left-hand side. And I think before we even look at the next slide, it may be important for me to mention a few things on the outside air. Now, outside air or ambient air, as you may call it, has a heat value. And it's very important that we understand this. So there is heat in air or temperature, and that is what the heat pump uses or absorbs or converts to the heating process of the water. So it's very, very important that we just understand that ambient air has a value. Think about it, early morning, nice and cold, cool air, but maybe about mid-afternoon, that is nice and warm, even in the shade. There's definitely value of free energy or heat in the air. Let's have a look at the process in the next slide. Byron, next slide, thank you. So before I start, you may have heard many people say, oh, a heat pump, it basically works like a fridge in reverse. That yes, they may seem to have some similar components, but the big difference is that the one heats water and the other one cools down its contents. With overcomplicating the heat pump process, I've really tried to break up the process into a very simplified, understandable manner, which I hope to make sense. So let's have a look at that, those steps that I've broken down for you. So a fan basically draws in the air over the evaporator. And so that's that nice hot or cool air goes over the evaporator. An evaporator acts as a heat collector. I just see it, it's like almost like a sponge. It collects that air, that ambient air. It's grabbing the air's heat. Obviously, there's liquid refrigerant in the evaporator, and that absorbs the heat in the ambient air, transforms it into the refrigerant or the liquid refrigerant in the evaporator, thereby warming it slightly. As soon as it's warmed, that warmed refrigerant, if you can follow the process, would be pumped then to a compressor to the right of the picture. That compressor then does a function. It compresses that warmed refrigerant further and makes it hotter. If I could use those words. Makes it hotter, turns that hot refrigerant into a gas, and then as the energy or the heating is increased, that then gas is then pumped to the heat exchanger, the far right-hand picture. It looks like a radiator. And that's where all the magic really happens, where the heat then gets transferred, from the hot to a cold. It's the law of thermodynamics. So what really happens is that water passes through the heat exchanger and the hot gas, as you have, to the cooler water. The refrigerant then after that would turn from a gas, its state then changes, moves from a gas back to a liquid state, and then is pumped through an expansion valve that you see on the top section of that diagram. And that then obviously turns it back into, make sure that it's into a liquid state, and then it goes through an evaporator coil. And then the whole process just starts over and over and over and over. And basically, I hope that has simplified it, or I've explained it, that you can try and understand the picture a little bit more easily. Thermodynamics is just basically, maybe because I did just mention the word, is the movement from, if you've got something hot, it'll obviously try and move from hot to cold. It's just the law of thermo being heat. And next slide for us. So why are heat pumps so popular? Well, let's have a look at those main headings. They're energy savings, they're money savings, they reduce the demand on the energy grid. Compliance to SANS 10400 XA is also one of those driving factors. As I mentioned, a heat pump basically uses the same amount of, can heat the same amount of water, but just obviously with less energy. Some of the heat pumps just use a third or a quarter of the electricity required as by an electrical geyser. And I believe that is a huge energy saving. As mentioned, remember that the heat pumps absorbs the heat that's already in the air and basically converts it. For consumers, that should signal a money saving. We all know what the price of electricity is and where it's going. So electricity is expensive, and using less of it basically makes huge sense. It makes perfect sense to consider these type of technologies. On the bottom left-hand corner of the slide, you'll see I've written geyser 3 kilowatt versus heat pump 1 kilowatt. I've put it there just to try and give you an illustration, just to try and point out a very important factor. Imagine if there's no electricity, we're all on load shedding, and we have 1,000 geysers with a 3 kilowatt element. As soon as the power comes on, all these geysers want to start up. And let's say, for example, you've got 100 geysers, 1,000 geysers with a 3 kilowatt element. That is 3,000 kilowatts of power that is required from the grid. Can you imagine if it was maybe only 1,000 geysers using 1 kilowatt of energy? That's a huge difference between 3,000 kilowatts versus 1,000 kilowatts. Another huge driving factor, as I mentioned, is the compliancy to SANS 10400 XA. Since November 2011, the National Building Regulation for Energy Efficiency for Buildings, XA2, applied. So XA2, ladies and gents, basically, I'm just going to read a little section. It says that at least 50% of the volume fraction of the annual average hot water heating required shall be, and shall be is quite a definite word. It's a must. It's not an if or maybe. It says it shall be provided by means other than electrical resistance heating. So think about other, could be, for example, solar heating, could be heat pumps, Could be even recovery from other type of systems and processes, and also maybe even renewable combustible fuel. So saying that, maybe you just need to consider that maybe a new building or an extension that is only with an electrical water heater may be considered illegal. That's one of those huge driving forces. We want to try and almost greener, less energy consumption. So it's definitely, these are the driving forces behind making, or some of the driving forces making heat pumps so popular. Byron, next slide, please. So which installation standard is used for the installation, maintenance, replacement, and repair of domestic air source water heat pump systems? Well, that is SANS 1352. Within the scope, and I'm not going to read everything to you, but I thought maybe just very important just to say that scope, or if you look at the scope within 1352, it basically covers the following. It covers the requirements for the safe and correct installation of both new and replacement domestic air source water heat pump systems, complete with all the relevant and applicable safety and hydraulic control units. It also covers in the scope integral domestic air source water heat pump units that fall within the scope of 151 up to, and it's very important, up to 500 liters for our listeners. So the integral domestic, I will touch on a little bit later and maybe just give an example of the difference between an integral and a split, as mentioned in the second slide. The other important thing is that the scope covers maintenance and repair, but excludes the repair of the heat pump unit. Now, these things have got PC boards and a whole lot of stuff, so the actual repair of the actual unit itself, that is unfortunately excluded. It covers the safe, correct, appropriate method of interconnecting domestic air source split, and the key is split remote water heat pump systems into a new or existing approved fixed electric storage water heating system. And I've basically put in black there, the retrofit. So it also covers the appropriate methods of the domestic heat pump's heating system installation to provide optimal energy efficiency of the heating system. What it doesn't cover is things like the hydraulic design of the system. Remember that it also, one of the normative standards that's got to be installed to SANS 10254 as well. So there are a lot of other normative standards, but if you're looking for the sizing and if you're looking for designs, I suggest that you look at SANS 10252 Part 1 for more information there. All right, can I ask you just to move to the next slide, please? So what is a split heat pump unit? Simply put, it's a unit that is split. So you'll have a heat pump. If you look at the diagram there, the heat pump's basically not joined to it, but joined via a circulation or primary circulation loop. The heat pump obviously fulfills its function. You might find that the storage heater is in the roof and the heat pump unit is outside. So a split pump heat unit is a system that has a storage container which is remote from the heat pump unit. You look at the diagram, I think it's important that these units have a circulation loop, as mentioned, but there's two. There's a return and a flow loop, and I just want to explain it. It will take 2 minutes just to quickly explain something because it is important. The flow is basically from the storage water heater to the heat pump unit inlet connection. So obviously, I'll explain a way I would remember it, but the flow, let's just touch on flow first. It's the storage water heater, from the storage water heater to the heat pump unit inlet connection. The return, you look at the outlet on the picture at the bottom, that's the outlet, and that is returning to the outlet connection of the storage water heater. So, as I say, I remember it in the following way. Cooler water flows to the inlet of the heat pump and warm water returns to the outlet connection of the storage water container. Let me just see if there's anything else I could maybe mention on the slide. I think the key is that it's split and it's separated, and that's why it's returned split heat pump unit. Byron, can we look at the next slide, please? Well, ladies and gents, this is the integral heat pump. What you're seeing in integral heat pump units are not split type. And therefore, you can't see an external primary loop as you saw in the previous slide. If you look at the definition, an integral heat pump unit is a heat pump system that has the storage container integrated, put together, joined together with the heat pump unit. It's a combined. So if you look at the picture on the right-hand side, as my notes say, it's a combination of the hot water cylinder with the heat pump mounted on the top. If you look at the picture on the left-hand side, you'll see it's a solid level base. These units are normally based outside. You can't go and wall mount them. You can't put them into places. It's for a level. It's got to be on a solid base. And obviously, the importance is integral. Integrate. It's one unit. And that's as simple as what it is. I know it does cause a little bit of confusion out in the market, and but I hope that I've explained it to a degree that you just need to see it as combined, and the one is split. Byron, next slide, please. So some common questions we get asked, and we received some phone calls on these kind of heat pumps. And one of them are, what happens if the heat pump unit fails? Will my clients still have hot water? And the answer is that within 1352, which is SANS 1352, it states that backup shall be provided in the event of a failure of the heat pump, or where additional short-term water heating boosting is required. So yes, it has to have a backup element or a backup power source to heat the element. Remember that boosting is only short-term, so as you can see in the wording. So if there's failure of the heat pump, or where you need that short-term heating, you can obviously, it could be electrical or any other approved means of backup. You might be able to maintain. So you do need these kind of backups systems. Next question is, can a split heat pump be positioned above a geyser? And the answer is, must check with the manufacturer. That's our advice. Check with the manufacturer if it's first of all allowed. And if it is allowed, I think the important thing that I need to stress is make sure that this provision has been made to prevent the heat pump from draining of water. So if you could imagine the heat pump it's got a pump, and it's in that circulation loop, and it's moving water. And if it's sucking water from a lower body of water, you might find there's a leak at the higher level, that it could be draining off that storage tank. Next question we normally get is, should I consider the manufacturer's instructions? And the simple answer is yes, notwithstanding the national standard, the heat pump unit and all its components shall be located and installed in accordance with the manufacturer's instructions. Next question, should all the components used in the assembly be of approved type and be matched in terms of the pressure rating of the system? Yes, as you see on the right-hand side, approved type is defined and approved by the local authority in whose area of jurisdiction the system is installed. It's very important, or by the administering body of the standard. So yes, it needs to be matched in terms of the pressure rating, and yes, those components in the assembly need to be of approved type. Next question we get is, must COCs be issued for the heat pumps? And I've copied a section from the standard, and the answer is yes. A per plumbing certificate of compliance shall be issued for the installation, replacement, repair of any plumbing works inspected, or where work has been carried out on a hot water reticulation system, which includes the installation of a heat pump unit for hot water heating purposes. They also need an electrical installation certificate. As you can see, 9.2 says you need an electrical certificate of compliance. Although the question doesn't refer to refrigerant or what happens, but you might be asking, so what happens if there's that liquid refrigerant we spoke about earlier is leaking or needs replacement repair? Well, point 10 in the standard also mentions the regassing, and that needs to be undertaken by a category 3 air conditioning and refrigerant practitioner registered with the South African Qualification and Certification Committee, which is SAQCC for gas, and the South African Refrigeration and Air Conditioning Contractors Association. So yes, there are definitely COCs that must be issued. The other question that comes up, and it's more from a understanding or misunderstanding, is this 11 meters that's referred to in the standard. It reads the 11 meter maximum linear distance for heat pumps outlet. So the 11 meter maximum linear distance from the heat pump outlet to the storage water heater return connection does not include the maximum does it include the maximum 3 meter vertical height? So what I've done is I've managed to, and I think we just need to stop and just say, well, what is linear distance? And for those who may not know, or the listeners that may do know, linear distance is the distance between two given points. So if, for example, the outlet of the heat pump and the return connection of the storage water heater. So on point 6, what I've done is I'd just like to maybe give you a little bit of on the next slide, I'll show you a little picture that I drew just to try and see if I can illustrate the answer to that question a little bit better. Byron, let me have a look here. So before we talk about my drawing, let's just have a look at the wording in SANS 1352, and it's under reference 5.5.1b. It says, in the case of a split type heat pump, if you can recall, there were two different types that I showed you, but the one that's separate, that's remote, the heat pump unit, the total linear distance between the pumped outlet connection of the heat pump unit and the return connection of the storage water heater shall not exceed 11 meters. And then in the standards, it's got in brackets, this includes the 3 meter maximum vertical head. I have also put at the bottom that the standard does say, unless otherwise stated by the relevant heat pump manufacturer. So it's very, very important to also consult with the heat pump manufacturer. You may find that they say, no, we wanted 9 meters, and then obviously you'd have to work within those confines or requirements, or they may even say slightly more. So please, it says otherwise stated by the relevant heat pump manufacturer. It's very, very important to know. So let's have a look at the picture. I've drawn a little heat pump on the left-hand side. On the top, I said inlet and outlet. So I've looked at the requirement. It says between the outlet connection, so the bottom in green, we have highlighted it, and the heat pump and the return connection. So I've drawn a line, and you'll see that it's like a red line that you're seeing going up. I've tried to indicate a 3 meter vertical height, and it's getting connected to the return connection of the storage water heater. So, dear listeners, it's basically 11 meters in total. So if you had 8 meters in total horizontal length, as an example, and you've used the 3, that's 8, 9, 10, it's 11. 11 may not exceed 11 meters. Vertical height. So if you can imagine the split pump unit being on the ground, and if you can think of vertical head, it's vertical up, so it's going up against the wall maybe, and then the pipe turns into the roof cavity and then goes to the storage water heater. So it's that vertical height from the outlet that needs to be taken into account and added up. Let me just see if there's anything else on that. And I think we're heading off to our last slide. Byron, thank you very much. So with that, I think I'm spot on with time today. It's 7:24 on my clock. I just want to say to the listeners, ladies and gents, today's session merely touched on domestic heat pumps. It was a very very simplified overview. I hope that I've excited you, and that was the aim, to excite you to the benefits and the energy savings these domestic heat pumps may bring to you and your customers, and definitely, as I mentioned, an alternative solution to heating water at a fraction of the cost of a standard electrical geysers. To those qualified plumbers that may be seeking more information, like where can I get started, where do we do the training on heat pumps, etc. I want to urge you to visit IOPSA's website. Strange enough, I wasn't part of my planning, I saw yesterday there was an announcement that I saw there was some and I'll quickly just open it up here on my side just to read this to you. So there was some free heat pump and solar training. Obviously, it's only for our members. So, obviously you've got to be a member to grab these benefits. There are some terms and conditions that do need to apply. And basically there are some, I think it's 15 heat pump and 15 solar courses that are up for grab. Obviously limited seats, specific times, on a first come, first served basis. So, but if there are any that want to inquire a little bit more about this, obviously hop onto our website and, engage with us. If there's anything you'd like to ask on today's session and you might feel like dropping an email to me, please do. My email is technical@iopsa.org. My name is Steve van Zyl. To all our listeners out there, thank you once again for making the time and the effort, logging on and joining the webinar. I wish you guys an awesome and a wonderful day ahead.